We are going to set up the famous tank mixing problem. You are going to deal with this problem later when we learn how to solve differential equations. We'll learn how to solve the entire problem, but for now we just want to set up the differential equation. So here's the scenario. We have a tank. It mixes brine instantaneously. As soon as salt is into it, we're assuming it gets well mixed very quickly. And we are pouring salt water or brine into this tank at 4 gallons per minute. That's a rate. And now the brine that we're pouring in there has a concentration of 2 pounds per gallon. That's how much salt is mixed into this brine. The tank overall is 300 gallons, and we are draining it after mixing it at a rate of 4 gallons per minute. So this is also a rate. The units are a big help in this problem. The units really help us understand, are we talking about a concentration or a rate, right? Or just a quantity. A has units of pounds, not pounds per gallon, not gallons per minute. A just has units of pounds. How much salt is in the tank at time t. So in order to set up a differential equation for this scenario, what we want to look at is the rate of change of the number of pounds in the tank. That is dA dt, or A prime, the derivative of A. And that is going to be equal to the rate in minus the rate out of salt. How much salt is coming in, how much salt is going out. The units of the derivative are pounds per minute, right? It is a rate of change of the number of pounds. So it has units of pounds per minute. So we got to think about how much salt is coming in per minute and how much salt is leaving this tank per minute. So coming in is the easier one to think about. We have a concentration of 2 pounds per gallon, and we have a rate of 4 gallons per minute. If we multiply those together, the gallon unit cancels, and we have 8 pounds per minute. That is a rate. Those are the units of the rate. So we are adding 8 pounds of salt every minute to this tank. The rate out is trickier. It's coming in, it's getting mixed up in here, and then it's draining. So how much salt is leaving every minute? To do that, we need to do something similar. What we did for the rate in is we multiplied the concentration by the rate. Now I know the rate. The rate is 4 gallons per minute. That is the rate at which we are draining the tank, 4 gallons per minute. But what is the concentration of salt in the tank? The concentration is going to be the total number of pounds divided by the total volume. So the concentration is A, that's the number of pounds, and the volume is 300 gallons. So once again, the gallons are going to cancel out here, and I don't like that this is sitting there alone, so I'm going to write it in. And we end up with A prime equals 8 pounds per minute minus 4 times A over 300. And that is a first order linear differential equation for this tank mixing problem. If we start with pure water in the tank, then we can say that initially there is no salt, and now it's not just a differential equation, now it's an initial value problem. If we started with a different amount, then that would affect the initial condition with however many pounds we started out with. This is the process, and this is always the process for setting up these tank mixing problems. We need to think about rates versus concentrations. We need to think about units, and the units are helpful. What units are we going for? How are these units canceling out? And then there's this key piece right here, where the concentration in the tank at time t is A of t over 300 gallons. That's pounds per volume, gives us the concentration, and then we're good to go.